Live from Earth, it's Space Radio. This is Paul Sutter, and coming up, we're talking about Next Stop, Ultima Thule. And of course, taking listener questions about all things in this wonderful universe, because that's what this show is about. We record every Thursday at 4 p.m. Eastern, so call 888-581-0708 to join the conversation. And in today's Blue Shift, I'll be talking about what it means to discover. But first, the news. Hello, space fans. Welcome to Space Radio. I'm Paul Sutter, astrophysicist at Ohio State, and for the next half hour, your agent of the stars. Got an exciting, wonderful, discovery-fueled show for you today on Space Radio, where we talk about this lovely little universe of ours. This show lives on listener questions. We record every Thursday at 4 p.m. Eastern right here. Yes, I am finally returned to home base, Studio A of WCBE Radio Columbus. So call 888-581-0708. You can also leave a voicemail at any time. Get those calls in. We'll have a nice little chat. You can also follow along on the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links, and you can join the Space Cadets tuning in live right now from all over the world, including but not limited to Sudbury, Ontario, Dublin, Ireland, Austin, Texas, Gandhar, India, Yatin, London, UK, Lancaster, California, Vipava or Yipava or Yipaya. Not exactly sure about the V versus Y sound on those. You get my point. In Slovenia, Orange County, California, Croatia, Czech Republic, Bulgaria, and Buckhead, Georgia. Thank you so much to all the Space Cadets tuning in live. And seriously, I've only prepped 10 minutes of show material tops, so get those calls in. And please correct my pronunciation of Vipava. Vipaya? I don't know. How's it going, Space Cadets? How you doing today? Get those questions in, and Nancy Graziano, the wonderful Nancy, she will put them up, mark them for me, and so I can do some. Do have a voicemail that I'm going to get to today, and but I'm curious what you guys are curious about. That's my jam. Before I start taking questions, I wanted to share some interesting bits of news I caught recently, and it's coming, folks. It's coming. So if you're listening to this live, if you're listening to the first broadcast, pay attention on New Year's. Don't watch the shows with the cheesy bands and the commentators and the people freezing. No, pay attention to space, because something remarkable is happening. The New Horizons spacecraft, this is NASA's mission to the outermost reaches of the solar system, passed by Pluto a few years ago, gave us our first true sense of what Pluto is really like as a world, is now approaching another target. It's been traveling in silence for all these years through the great interstellar void, and is now at a region in our solar system that is totally unexplored. Totally unexplored. We only know of this region, something we call the Kuiper Belt, through little dots of light and little smudges. And for the first time in human history, assuming everything goes well and everything's looking good so far, for the first time in human history, we'll have a map of an object in the Kuiper Belt. Not a fuzzy picture, not a dot of light, not just an orbit, something to sketch out. No, an image, a map. There will be features that we can name. This is a small object. It's very mysterious. It might be two separate objects. It might be a single lumpy one. Its name right now, and hopefully it becomes its official name, is Ultima Thule, which means at the boundary of the known world, the farthest thing known, the wildest parts. And this really is. Of course, there's more stuff in our solar system past this object, but this is the farthest that we have maps. This is the farthest that we have names and features that are known. The New Horizons spacecraft is blazing towards it at 35,000 miles an hour. This object is 4 billion miles away. That is a genuine Sagan B right there, 4 billion miles away from us. And this spacecraft, New Horizons, is coming within 3,500 miles of the surface. So 3,500 miles sounds like a lot, but 3,500 miles compared to 4 billion miles of distance traveled is quite an achievement. So the New Horizons spacecraft has been imaging this object, Ultima Thule, for a while, looking for potential hazards, making sure the path is clear. Everything seems clear right now. There are already mysteries about this object. It's been watching it for a while, and its brightness hasn't changed at all. And usually as things rotate, we get a sense of brightness and darkness as there's different features, but it's been almost uniformly bright. We don't fully understand what's going on. All we know is that there are going to be surprises. All we know is that we're going to answer a dozen questions and raise 100 more. This is what it means to push the limits of human knowledge, to push the boundaries of our maps. This is our home. The Kuiper Belt is our backyard. The Kuiper Belt holds secrets to the formation of the solar system itself. It's a time capsule. It's a preservation of our own history of 4 billion years of the history of our solar system. And this object, Ultima Thule, at the boundary of the known world, is remarkable. And I'm already calling it. We haven't reached it yet. It's already remarkable, and I can't wait till next week so we see a picture of it. And that's the latest and greatest when it comes to space, but it's time to have a conversation. All right. Nancy, thank you. Oh, man, tons of questions. I love it. So I'm going to do a voicemail in this segment, and then I'll probably pick one of these questions. Oh, okay. This is a great question. Approximately how many objects are there in the far end of the solar system? Great question. I'm going to answer. Is your name... How do you pronounce your name? Because it's coming up in Greek letters. Or no, it's coming up in Cyrillic. Sorry. Is it Mihail? Is that how you pronounce your name? Go ahead and correct me on the chat, and then hopefully I'll see it while I'm reading the next question, while I'm doing the voicemail.
Hello, Spaceman. This is Noble.
Whoops. Sorry, Greg. Now I have to reset the thing. See, we play a joke on the show. I say, Greg, play the tape. Really, I'm pressing the button that plays the voicemail. That is the secret of radio here, where I do most of the work. And Greg sits there.
Hello, Space.
Why do I keep hitting this button? This is good. You can tell it's been a while since I've been in the studio. You can tell it's been a while. Because I want to hit the button. Like, I feel like this is the button. My timer is over here. I need to hit this button so I know what I'm doing. We've got a voicemail to get today's show started. So it's all queued up. Greg, play the tape.
Hello, Spaceman. This is Noble here from deep in the heart of Texas near Fredericksburg. I had just a quick question for you. If I wanted to build, say, a space telescope large enough to be able to take a visual image of, say, like a cow on an exoplanet 150 light years away, how big would that telescope have to be? All right, thanks, man.
Wonderful question, Noble, about basic astronomy. And I don't know why, you're probably just familiar with cows and you're hoping to see another cow on another planet. That is definitely a biosignature, the sign of alien life. If we got a picture of another cow on a planet 150 light years away from the Earth. So I'll go with it. I'll pick any object. We'll pick a cow. And the wonderful thing about astronomy, about telescopes, first off, I can't think of the number off the top of my head of how big your telescope should be, but I'll give you a sense of how big it should be. A telescope is a giant eyeball. A telescope is a giant eyeball. It is a bucket for light, so lots of light can fall into a telescope. Like if you imagine looking at something, there's a lot of light entering your eye, and that's what you get to see. But there's also a bunch of light hitting your face and your cheeks and your forehead, and you don't get to use that light for any image processing purposes. It might warm you up a little bit, but that's it. Imagine if you had an eye the size of your head and you could suck up all that light, and that's very useful. And the second thing a telescope does is it magnifies, because it takes all this light and it focuses it onto a very, very tiny area so that you can see it or so you can take a picture. And that act of focusing magnifies. And the bigger the diameter of your dish, the bigger the lens, the smaller the object you can see. So if you have big eyes, you can see small things, you can see far away things. Now, something like a cow at a distance of something like 150 light years, I don't know the exact number off the top of my head. I'm going to ballpark, and this is pure guesswork, ballpark. I'm basically making it up, but it gives you a sense of scale. Is a telescope the size of, I don't know, the solar system? A telescope the size of the solar. If you want a picture of a cow, which is, how long is a cow? 10 feet, ish. I'm not exactly sure of bovine dimensions here, but somewhere around 10 feet. So you're looking at somewhere 10 feet at 150 light years away. We're talking trillions of miles there. Probably bigger than a solar system. Probably the chat is going to do the math, because there's a very, very simple equation that relates the diameter of your dish to the smallest thing you can see. And someone in the chat, I'm hoping, is going to plug in those numbers for me and actually give me the diameter. And we'll see how close I got with my guess for the width of the solar system. Now, following up on that and following up on my discussion of Ultima Thule, we had this wonderful question in the Space Cadet chats asking approximately how many objects are there in the far end of the solar system? How much is combined mass compared to, say, the mass of the 8 planets? Do we have any idea about that? We do have some estimate. There's a lot of stuff going on in the back end of our solar system. You've got the planets, of course. Then you have what we call the trans-Neptunian objects. These are the objects that are just past Neptune: Pluto, Eris, Makemake, and friends. Then you have something called the Kuiper Belt, which is where Ultima Thule is located. Then you have something called the scattered disk, which is home to a bunch of small or short period comets. My book fell. Sorry, Greg. I got all excited and my book fell. Sorry, you're actually going to have to edit this segment and do a little bit of work. You know what? Let's skip the book today, folks. Let's skip the book today. First time back in the studio in a while, so it's going to be a little rough. Where was I? Past the scattered disk, you have something called the Oort cloud, which is the ultimate remnants of the solar system, the last little frozen bits left over from the formation of the solar system. That thing goes on forever, like a light year away. There's a lot of members in the Kuiper Belt, the scattered disk, and the Oort cloud. We're talking billions, maybe trillions of individual members, but each individual member is like a boulder or a rock, or if you're lucky, the size of a house, or a tiny, tiny, tiny moon when it comes to some exceptionally sized object. So the total mass of the Kuiper Belt, the scattered disk, and the Oort cloud, somewhere around 50 times the mass of the Earth. Like, not a lot of stuff. And that sounds like a lot. Like, wow, 50 Earths is a lot of stuff. That's not a lot of stuff when it's spread out over so much ridiculous volume. Wonderful question there. And don't forget, you can call 888-581-0708 if you want to talk to me live on the show, or you can join all those other awesome Space Cadets on YouTube and Twitch. Go to spaceradioshow.com for the links. I'm Paul Sutter. This is Space Radio, and this show is brought to you by you. Go to patreon.com/PMSutter to learn how you, yes, you and only you, can support this show. I'll see you after the break. Wow, rough segment. I am off my game. I was hoping I would just come in. It's like riding a bike, like got my studio set up and just I can wave my arms around like crazy, but no, I'm knocking my books off. I'm getting my buttons wrong. Patience, chat. I don't know how to do this. What a conundrum. Someone's not liking how I'm pronouncing Kuiper. Is it Kuiper? Tell me. And does it matter? Does it really matter? Ooh, thoughts about living on Mars. Does time stop inside of a black hole? And will the Earth lunar system ever be classified as a binary system? These are three great questions right in a row. Jim Becker, pure ostentation. Ostension. I want to get your name right. Oh, and can I plug my book? I can plug my book all day long. Sorry. We're gonna move on. Welcome back, everyone. I'm Paul Sutter, and this is Space Radio. We've got more Space Cadet questions ready to go. And you can join the conversation by calling 888-581-0708. You can also leave a voicemail anytime, like Noble deep in the heart of Texas did. And you can also check out spaceradioshow.com for the links to the live streams. We've got tons of questions, so I'm going to do a little bit of a rapid fire here to get through a bunch of the questions. First off, Jim Becker on YouTube asking, does time stop inside of a black hole? If you were to fall into a black hole, time will not stop for you. In fact, time will keep on ticking, but there is a deadly fate awaiting you. As soon as you cross the event horizon of a black hole, you can start the countdown. Because according to a watch on your wrist, which is the only time that matters to you because that's your time, in the physics jargon we call this proper time, according to your proper time, as soon as you hit the event horizon, as soon as you hit the boundary of that black hole, you will hit the singularity. You will fall into the very center, and you will do it in a finite amount of time. You will do it if you're in free, and there's nothing you can do about it. That's the crazy part inside of a black hole. You can swim, you can fight, you can struggle. It doesn't matter. You will hit the singularity. And in fact, the worst thing you can do is try to fight it. That will actually shorten the amount of time it takes for you to reach the singularity. The longest path is the free fall path where you're not doing anything. You're just coasting along, accepting your fate. You will hit the singularity. For a small black hole that's, say, like 10 times the mass of the sun, we're talking half a microsecond between event horizon and singularity. For a giant black hole, if you're up at a billion or so times the mass of the sun, you're talking like 10 seconds tops. 10 seconds. And you can count them out. You cross that event horizon, 10, 9, 8. You get the rest. You get down, as soon as you hit zero, boom, you're in the singularity. Time doesn't stop, but your fate is sealed. Excellent question. Moving on to pure ostension, asking thoughts about living on Mars. So I am not a fan. I am not a fan of living on Mars. I don't like red. I don't particularly like cold weather. Makes me wonder why I live in Columbus. I don't particularly like living underground. I particularly don't like deadly cosmic radiation that can cause cancer. Not a fan. Not exactly a fan of poison, rocket fuel, literally in the soil. Not a fan of lack of liquid water. I love liquid water. If I have an opportunity to drink liquid water, I'll take it. Mars, not a lot of opportunities. I'm personally not particularly interested in going to Mars. Maybe for a couple days. A long weekend at most, like a Memorial Day trip to Mars. But other than that, I'm not really. And it's hard. Living on Mars is so hard. It is so hard. It is so far away. And there's nothing there. There's just a bunch of red, stupid dirt and carbon dioxide. And there is frozen water on the surface. I'll give you that. But there's like nothing. There's like all this. If you look around the room you're in right now. Or if you're in a car, look around, look at all this stuff and look at all the different kind of things it's made of. None of that is on Mars. You have to build it out of that stupid red dirt. All of it. Can you imagine how boring the interior decoration is going to be? You're really limiting your fashion choices by living on Mars. It's just hard. So, will we eventually send people to Mars? Most likely. Within our lifetimes, a good chance. Will we have a permanent human colony on Mars? It's not impossible. I'm not here to say it's impossible. It is exceedingly, exceedingly difficult to have a permanent human presence on Mars because there's nothing there. And it's also very far away. Now, next question. Dwayne Duvall, can you plug your book? All your own writing, other contributors, how many pages? You know I'm going to take this question. I can plug my book all day long. For those of you who don't know, all three of you who haven't heard the news, I wrote a book. It's available in bookstores nationwide, also Amazon. You can also buy autographed copies of my website. I mail them out to you directly. I sign them with my own hands. I wrap them in bubble paper bubble wrap with my own hands. I print the stamp. I do it all myself, and it's a labor of love. My book is called Your Place in the Universe: Understanding Our Big Messy Existence. It is a story about our universe. It's a story of the history of our very own cosmos and the history of how we came to know it. It's a story of curiosity. It is a love letter to the universe. And if you've ever read one of my love letters, most of you probably haven't, but if you could, there's a lot of bad jokes, a lot of poorly thought out metaphors and analogies, a lot of lame puns. That's my style of love. It involves a lot of sarcasm. And so my love letter to the universe includes a lot of funny stories. It includes a lot of jokes. It's about our universe. The goal of this book is that when you're done reading it, you kind of get the big picture. You kind of get the big picture. And I wrote it with my own hand on myself. I wrote it a year ago. It was my entire life for about 5 months. I remember it was the only thing I did. Like, I'd go to work, I do this, I do space radio, or whatever, and I would come home and got to work on the book. And it was just me and my laptop typing away. And how many pages it is, I don't know, because I'm holding right now a preview copy, not the full hardback. It's like 300-ish pages, I think, maybe 200. It's 86,000 words. 86,000 words of pure cosmological bliss. I, of course, had editors. I have an agent. Like, there's a whole team behind a book. The artifact of the book is not solely due to my own hands. I was just responsible for the wordy bits. There was a cover designer. I have an agent. There was Prometheus Publishers who did the work of, actually printing and distributing it, and, line editors and copy editors and the whole apparatus and publicists and the whole deal. So I wrote the thing, but there's a whole team behind actually making the book real, and I'm very happy to be part of that wonderful team. It's published by Prometheus, wonderful people to work with, and I am represented by Lane Haymont, the best agent in this cold, dark, empty universe, and I'm happy to say that anytime. Go buy the book. Go buy it in a bookstore. Go buy it on Amazon. Go buy it from my website, pmsutter.com. Just buy the book. It's a fun book. Now, I have time for one more question. Think I can do it? James May is asking, with all the new exoplanets being discovered and needing better definitions, will the Earth lunar system ever be classified as a binary system? This is wonderfully fascinating because the Earth is unique. The Earth is unique. Look at Mercury. Mercury, no moons. Look at Venus. Venus, no moons. Mars, 2 little tiny moons. I mean, they don't count, okay? Sorry, Mars, you don't have moons. Earth, big, fat, giant moon. It's like a quarter the size of our own planet. That is huge. You have to imagine if some alien species was hunting for exoplanets and came upon the Earth and they said, wow, look at that. If they saw us, would they say, hey, look at that cool looking binary planet? One's bigger than the other, but basically a binary. Would they say that? Would they be justified in saying that? That's a very interesting question. Right now, I don't think so, because the moon is very, very different from the Earth. The moon is much smaller than the Earth, so small that the center of our mutual orbit is inside the Earth. But we get big tides. We came from a common origin. We were kind of born together due to a giant impact. It's a little bit complicated, isn't it? And the more worlds we discover, the more variety of worlds we discover, who knows how definitions might change. Thank you so much for all those wonderful questions. We're almost out of time today on Space Radio, but before we go, it's time for the Blue Shift. And Greg, if I'm not mistaken, I need to keep this blue shift a little bit short. Yeah, a little bit short. So the reason I'm leaning, by the way, to talk to Greg is my light is here directly, so I can't see Greg during the show. I can't see him nodding off or reading the newspaper, so which is good, actually. It's fewer distractions. So I want to get visual confirmation. So to do that, I have to go here. There he is. How's it going, Greg? stay. We're almost done with the show, but after we're done, I'm going to eat some cheese and Greg's going to join me. So just hold on after the blue shift. I'm not going to make it a part of the blue shift yet. What I want to talk about for the blue shift, discovery. I'm Paul Sutter, and you're listening to Space Radio, and this is the Blue Shift, my opportunity to get a little bit closer to you. And what I want to talk about today, especially motivated by this news, the upcoming mission or the upcoming arrival of New Horizons at Ultima Thule, is the nature of discovery, and especially scientific discovery. Because we're used to this idea of discovery as being physically present, like an explorer standing on a mountaintop, looking out to the horizon saying, I discover you, and I'm going to name you, a river, and, actually seeing it and mapping it and charting it. And that's exactly what we're doing in the outermost reaches of our solar system. This week, we are mapping, we are charting, we are discovering, and it is all glorious. It is all beautiful, but there's another kind of discovery. There is the mental discovery. There is the mathematical and physical discovery. There is discoveries into the insights into how nature works. And those insights can happen by raw observation. Those insights can happen through laboratory experiments and collisions. They can also happen through pure mathematics. This is the power of mathematics, one of the many powers of mathematics, and the reason we use it in physics and why physics is different from philosophy, and not knocking philosophy, but there is a difference. One of the differences is the use of mathematics, where we can discover, we can form models of the universe around us, of the world around us. We can discover relationships. We can discover consequences. We can unlock new knowledge just through the application of mathematics. We have discovered, there are many, many examples of fundamental particles or epochs in our universe discovered just through math, of applying some mathematical tools, following them to their natural consequences, and discover, oh, there's something new here. There's something, we should go look for that. That is a discovery. That is pushing at the edge of human knowledge. And unfortunately, this broadcast is almost done. Thank you for joining me on this voyage of space radio. Once again, I'm Paul Sutter, and this show is brought to you by the Ohio State University Department of Astronomy. Learn more at astronomy.osu.edu. The show is also brought to you by you. Go to patreon.com/pmsutter to learn how you can contribute. Thanks to the wonderful Greg Moebius for producing, Nancy Graziano, who is also wonderful for wrangling the Space Cadets, the sufficiently wonderful Dan Michalko for being awesome, and all the fine crew at WCBE Radio for making this show possible. We record every Thursday at 4 p.m. Eastern. Call 888-581-0708 to join the conversation. You can also drop a voicemail at any time. You can also follow the live streams on YouTube and Twitch. Go to spaceradioshow.com for the links. And of course, thanks again, Earthlings, for listening. See you next week. And remember, science is for sharing. End of transmission. Okay, so Stella got her groove back in the back half of that show. I'm Stella, by the way. I'm Stella. Hey, Nancy, can you ban Radio Eyes? Thank you. I don't like the way you talk, mister. Hey, stay on the show. Greg, come in. Oh, Greg's got to do the things to close the show. I've got a cheese I want to share with Greg, and we can chat, live streamers. Nancy's good at wrangling. Pull up a chair, Greg.
Sure.
Let's eat some cheese.
Okay. Did you make this?
I did not make this cheese.
Right.
I bought it.
Okay.
And they didn't sponsor it, so I'm not going to name where I got it from. I'm not going to name the brand or anything because, you got to pay for that kind of privilege. But this is a lovely, I've had a few bites already. It's called a barely buzzed cheese. Has a little bit of honey in it. It's a cow's milk. Black. Wow, I mean, look at this really rind. Good. Look at this rind, guys. Isn't that amazing? Look at that texture.
That was really good.
So I don't know if they infused it with honey or they just coated it in honey and let the flavor sink.
Right.
But there's that little subtle hint, just a tiny, tiny bit
Mm-hmm.
of sweetness. Some definitely like woodsy, earthy tones.
Mm-hmm.
It's so good.
What's the name of that?
I don't know. It's called, well, its name is Barely Buzzed, as in bee buzzed.
Okay.
Okay. But I forgot the brand because I threw away the label.
What's this? Same?
Same. It's all the same.
Oh, okay.
It's all, yeah.
Even with this coating on the back?
You want to eat the rind?
Yeah. Can I?
Greg can eat the rind. Eat the rind. Eat the rind. It's probably going to be really intense. It's edible, but just like, you like
Woodsy.
it? Woodsy, deep, woodsy. Greg's in the deep forest now.
That is strange.
That is strange.
Mm-hmm.
You're probably going to die now. You're going to get hair cancer.
A lot of E. coli. And
Yeah.
I prefer it without the woodsy taste.
That was a little bit too deep. Rinds are wonderful if you really want that intense.
Mm-hmm. Mm-hmm.
This is I really like this cheese because it doesn't need anything else. Like it's a complete package.
Do you eat cheese with every meal? You're such a fan.
Do I eat cheese with everything?
On your eggs in the morning, burgers in the afternoon.
No. Actually, no.
Mm-hmm.
You know why? Because I can't afford it.
Really?
No, I can afford cheese every meal.
A
Come on,
published
I'm a player.
author cannot afford it.
You want to see my royalty check and then you ask that question again?
Give it time. These things take time.
They take time. Here, last two pieces.
Okay.
Last two pieces. There you go.
All right, thank you.
This is just
It's really good. You know, I don't eat a lot of cheese. Unlike you, I don't.
I can tell.
Because there's a lot of saturated fat in cheese.
That's called flavor.
I know.
Flavor and mouthfeel.
How can you tell I don't eat a lot of cheese?
Oh, I see it in your eyes. It's the soulless, sunken ghost shell of a human being. It's the clear signs of a man who does not eat enough cheese. Chat's going crazy, still asking questions. But this is a very good cheese.
Mm-hmm.
This is a very good cheese. Barely Buzzed is the name of the cheese. I'm not going to tell you the brand or where I bought it. Fair enough?
Boy, yeah.
That's a solid
delicious.
cheese.
It really is.
That was lovely.
He knows his cheese, folks.
I know how to eat cheese. That's what I know.
Thank you for inviting me. That's awesome.
Absolutely. Anytime, Greg.
All right.
Which is probably going to be next week.
Okay.
Okay. Fair enough.
All right.
All right. I got to go home, folks. Take it easy, everyone. Thanks so much